Hello everyone, here's JJ. This video, I will bring you guys a review, some question for next assessment from topic 1 to topic 3 with calculator. Yeah, with calculator, this one. So let's go. So I will skip first question, fourth question, and sixth question because we did similar question or we did exactly same question before. Also I think for question 4 is just using calculator, you can find the answer, so I skip it. So let's go. 8 runners compete in a race where there are no tight finishes. No tight finishes is a key word. Anli and Jack are 2 of the 8 competitors in this race. Find the total number of possible ways in which the 8 runners can finish if Jack finishes in the position immediately after Anli. So before we start, I want to bring you guys review some methods we use to solve that kind of question. First, package method. For example, for question A, because Jack finishes immediately after Anli, therefore we can put Anli and Jack in a package and imagine that they are one stuff. We deal them as one object. Therefore, there will be another six students, other runners. Anyway, so in total there's 7 objects. And to order like 7 objects, here's like 7 factorial way to like order them. So it is the answer. So it is package method, which means we can deal some amount of object as one object and using permutation to find the total way. Does that make sense? So it is question A. And okay, sorry. And let's look at second question. Find the total number of possible ways in which the 8 runners can finish if Jack finishes in any position after Anli. So for question B, I will introduce a general way, also a general method, insert, or for question B, here's a special way to do that. So I will start with general method, insert. So because we have to deal with Jack and Anli, because the condition is only related to these 2 runners, so we can first ignore them and let's calculate how many ways can we put these 6 other runners in 6 position? So obviously there's 6 factorial way to arrange the 6 runners. And then look. Wait. So if Anli is here, it is what insert mean. So it's like we already order like the 6 runners. Therefore, we can just insert Anli and Jack between 2 runners, or maybe in front of first runners or after the last runner. So if Anli is here, how many way can we like put Jack and at the same time follow the condition in any position after Anli? So let's count. So Jack can be here, 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 can be here. 1, 2, 3, 4, 5, 6, 7. What if Anli is here? Then Jack can be here, 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 can be here. And same, if Anli is here, then Jack can be here, 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 here. Oh wait, let me make it more clear. I guess you guys already find the pattern. So if we put Anli in front of first this random runners, there's 7 way. Oh, why is random? So it is 7 way. Then later 6 way, 5 way, 4 way, 3 way, 2 way, 1 way. I mean, this 1 way is like this 6 student, then Anli, then Jack, till 1. So we know that here's 6 factorial way to arrange these 6 other runners, and here's in total 6 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 way to insert Anli and Jack in between, in the 6 other runners. So in total we can know that there's 6 factorial time 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 way that Jack finishes in any position after Anli. So let's calculate it. 6 factorial time 28. And 28 is equal 4 times 7 times 6 factorial, which is equal to 8 times 7 times 6 factorial but divided by 2. So the answer is equal 8 factorial over 2. It's a general way to solve that kind of question. So this method is called insert. You can insert the stuff after the unrelated object. It's easy to achieve the condition the question asks. Okay, as I said, for this question, here's a special way to do that. Let me explain it to you. For example, I find a way this 6 other student, Anlia and Jack. Right now, I found a situation that Jack finishes after Anlia, right? The thing is, if I find a way that Jack finishes after Anlia, if I swap J and A, then we will get a situation. That Jack finishes before Anlia. I don't know if you guys can understand what I mean. Because there are no tight finishes. Therefore, in theory, the total number of possible way if Jack finishes in any position after Anlia is equal to total number way if Jack finishes in any position before Anlia. Therefore, we could just calculate the total number of possible way to run 8 runners, which is 8 factorial. And because the total possible way that Anlia finishes before Jack and Anlia before after Jack are same, so we only have to divide it by 2. You'll get exactly the same answer. Then we just use calculator. Right? So for this specific question, you can use this way. But when you use this way, you have to write a sentence to explain the total number of the way that Anlia finished before Jack is same as total number ways that Jack finished before Anlia, something like that. So that's it. Okay, let's continue. So let's look at question 3. It's something really general, right? Consider the equation blah 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 blah, where these from a complex number and p belong to real number. 3 of the roots of the equation are 3 plus I, a alpha, and alpha squared, where alpha belong to real number. By considering the product of all the roots of equation, find the value of alpha. So, yeah, I mean, if 3 plus I is one of the roots, therefore 3 minus I is also one of the roots. So R1, R2, and R3 is equal alpha, R4 is equal to alpha squared. And by considering the product of all the roots, so it's ready to tell us the method. So let's see. According to the formula, is minus 1 to the power of n, which is 4, then time a0 over an is equal to the product of all the roots, which is 3 plus I, 3 minus I, alpha squared. Therefore, we will get AT is equal to 10 times alpha to the power of 3 So yeah, alpha cube is equal to 8, alpha is equal to 2. Okay, something in general. Then they ask us find the value of P. P is at a really good position. Why? Because P is an minus 1. An-1 is related to the sum of all the roots in equation. So we know that minus P over 1 is equal to the sum of them. So which is 3 plus I plus 3 minus I plus alpha, which is 2, alpha squared, which is 4. You get minus negative P is equal 6 plus 4 plus 2, which is 12. So P is equal to negative 12. So guys, I will teach you guys how to check your answer if you still have time during the exam. In this case, calculating a complex number like with power something is not convenient. Compared to 2 and 4, 2 is smaller. Therefore, because this paper is with calculator, then you can put negative 12 back and you put 2 in the equation and check. So 2 to the power of 4 minus 12 times 2 to the power of 3 plus 54 times 2 squared minus 108 times 2 then plus 80, and just check is that equal to 0. So let me show you guys. So 2 to the power of 4 is 16, yeah, true. And let's see, guys, look at this. 54 times 2 squared is equal to 54 times 2 times 2. 54 times 2 is 108 times 2 is these two terms are same, so we can cancel that out. Yeah, we already checked this. And 16, let's check this part. 8 times 12 plus 18. 8, 12. If you have good feeling about number, you realize that 8 is 10 minus 2, 12 is 10 plus 2, so you can use, you first add these two together, 96, then you can plus, you can minus 100 minus 4. Use a difference of square, how is that called? Yeah. A minus b times a plus b is equal to a squared minus b squared. So 100 minus 4 is 96, so it's equal to 0, which is correct. So you can check the answer by yourself like that. Yeah. Yeah, I mean, you don't have to calculate by yourself, like because I mean we have calculator, right? So yeah. Okay, perfectly. My storage ran out. So what can I say, man? I will like quickly go through everything. So for the question 5, first question, you can just use according to the question, calculate those stuff by calculator. But be careful. It will be better if you calculate the start of 2019, then get the result and put it back, use the result times 93%, then plus 250. Because I promise somebody might make mistake. For example, they will eat the bracket. Yes, I mean, I know that some of you guys might be hungry during the math class because, yeah, it spent a lot of energy to do math, but really, please. I mean, if you want, I can give you guys some snacks, but don't eat a bracket, okay? Please. And let's talk about question B. For question B, I really want to introduce a way to solve that kind of question, because obviously we cannot calculate like the number of fish in the lake at the start of 2042 by calculating 1 year by 1 year. It does not make sense, right? Therefore, we have to find a general formula to calculate that. In order to find a pattern, find the equation, it's easier or it's more clear to use letter to replace some information. For example, decrease by 7%, I use rate, I use letter R. So R is equal to 93%, because when we really calculate it, we realize that time 1 minus 7% is equal just directly time 93%. So yeah. And then add 250 new fish, so I use letter A. And because the question starts at 2018, so I use U1 to describe 2,500. So let's find a pattern. 2018 is U1, 2019 is RU1 plus A, 2020 is something blah blah blah. After you simplify, you get R squared U1 plus AR plus A. Later on, look at this. Let's try to find a pattern. So by observing first term, we realize that 2018 is R to the power of 0, which is 1 times U1. 2019 is 2018 plus 1. So its first term will be R to the power of 1 times U1. 2020 is 2018 plus 2. So here is R to the power of 2 times U1. Same for here, R cubed U1, R to the power of 4 U1. So 2042 is 2018 plus 24. The first term will be R to the power of 24 times U1. And let's look at another stuff. No, nothing. AR plus A. AR squared, AR, AR cubed, AR squared, AR, A. If you are sensitive to sequence this topic, you realize that it's a geometric sequence. So by calculating the series by this formula, we know that. Here is, for example, 2022, those stuff will be A to the power of A times R to the power of 4 minus 1 over R minus 1. Does that make sense? It's a geometric sequence. So let's see. If first term is R to the power of 4, then the thing here above the fraction is also R to the power of 4. R to the power of 4 minus 1 over R minus 1 times A. So we know that in 2042 you should get R to the power of 24 U1 plus A times R to the power of 24 minus 1 over R minus 1. So it is general formula equation. So in the test, you can directly show the examiner that you find a pattern by this way. Then you just put all the information back to here, then you can calculate the result. So why is better to use letter to replace those stuff? Because on the because remember, the formula booklet always show you something general, won't show you some specific number, something like here. So it will just show, for example, show you 2018 plus 2019 plus 2020 plus 2019 plus 2020 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 how do you calculate the geometric series? So when you saw something like that, letter, not only it looks clear, but also you won't get disturbed by the annoying number, because those numbers you see is when you sign also really long, 250, 2,500, 93%. Those stuff will make your mind like messy. So yeah, it's an easy way to avoid that situation. Normally, last question is the hardest question in the paper, but actually, question 7 is much more interesting than question 8. Therefore, I will do question 8 first. So, if you watched my last video about assessment result calculator, you guys might remember something. For example, Jesus, 3x plus 5 over x minus 2. How do you find horizontal asymptote as soon as possible? Is by, we can do that by x minus 2. Let's first let x minus 2 equal to 0, then we know that x equal to 2. So right now, put 2 to the thing at the top, which is 3x plus 5. So if we let x equal to 2, then we will get 3 times 2 plus 5, which is 11. So the basic mechanism is like we let the thing at bottom equal to 0 and solve how much is x. Then we put x to the top and we'll get the number, which is 11. So we know that. Then we can know that this stuff should equal to something plus 11 over x minus 2. Or we can do it like that. X minus 2, because we get 11, so after we write 3x plus 5 down, we can plus 11 at the end, but it's not equal anymore, right? So we minus 11 before we add 11, then with a bracket, and let this plus 11, the thing we get it here, like independent? Yeah, independent. So tell me, 3x plus 5 minus 11 equal to, yes, 3x minus 6 over x minus 2 plus 11 over x minus 2. So the first term, you will realize that we can get, we can factorize it because 3 is a common factor for 3x and minus 6. So we'll get 3 times x minus 2 over x minus, divided by 2. We'll get 3 times x minus 2, bracket, okay, over x minus 2. Then plus 11 over x minus 2. The thing is, x minus 2, we can like cancel that out. So we get 3 plus 11 over x minus 2. So 3, so y equal to 3 is a horizontal asymptote, yeah. So if you guys remember how did I explain that, you will know that actually I'm trying to find the remainder. So in this case, the remainder we get from 3x plus 4 divided by x minus 2 is 11. So 11 is the remainder. That's why at the end you get the horizontal asymptote plus remainder over the thing at the bottom. So let's go through the question. So for first question, find the equation of vertical asymptote of the graph of x of fx. So fx is x squared minus 14 plus 24 over 2x plus 6, right? Yeah, the thing, if we want to find the vertical asymptote, we just let 2x plus 6 equal to 0, and we will get x equal to -3. It's something basic. And find the coordinate of point where the graph of f crosses the x-axis. The coordinate of points cross the x-axis, which means the root. So, even though we have a calculator, you can use a graph to find, but it's not that clear. We still have to if you want to show it, how did you do that? So, just solve equation that x squared minus 14x plus 24 equal to 0. But at the same time, you have to make sure that x does not equal to -3. Okay? Do you know why? Because in the real, if we put -3 here, we'll get something divided by 0. So sometimes the result, sometimes -3, like something like that. The vertical asymptote might be the one of the root of the thing at the top. So make sure that you check if x is valuable or x is in the domain of this function. First, so in this case, x equal -3 is not in the domain of this function, right? So by solving this equation, we know that x1 is equal to x1 is equal to 2, x2 is equal to 12. And then for question C is let us find the oblique asymptote. Yes, it's a thing I wanna. It's a question I wanna talk about. We can use similar method. So we know that. So we know that when x equal to -3, the bottom will equal to 0. And right now, put -3 to thing here. Let's get the remainder. So -3 squared minus 14x, which is -3, then plus 24. We'll get 9 plus 42 plus 24, you'll get 75. So 75 is remainder. So I like this green pen. So x squared minus 14x plus 24 minus 75 plus 75 over 2x plus 6. Then later on, x squared minus 14x minus 51 over 2x plus 6 plus 75 over 2x plus 6. And factorize the thing here is where's negative 51 from. Factorize, you will get x minus 17 times x plus 3 is equal to 2 times x plus 3. Later, therefore, you will get x minus 7 over 2 plus 75 over 2x plus 6. Then you should get 1 over 2 times x minus 17 over 2 plus 75 over 2x plus 6. So obviously, the thing here, 1 over 2x minus 17 over 2 is the oblique asymptote. So a is equal 1 over 2, b is equal negative 17 over 2. And yeah, by using a calculator, you will find a graph that looks like that. And there should be a, oh sorry, this graph is not that good. You should find the asymptote like that. Vertical asymptote, oblique asymptote. The graph looks like that. Then you just sketch it because you already get two asymptotes. And use calculator, you can check your shape, and also you can calculate the intersection by yourself because we already calculated two intersection here. Oh, remember it's coordinate, question asks coordinate, so 2.0 and 12,0. And for there, when you draw the graph, also make sure that you mark. It showing clear the asymptote and any intersection with the axis. And also find the range of f. You see, range is just like how much can y be. So you just find the minimum point of here and maximum point of here. Then the range will be the thing here and the thing here. So you should get like x more than, if it is equal to a, and or the minimum point equal to a, maximum point equal to b. So the answer you should write something like x more than a or x less than b. It's the range of f. And solving the inequality fx more than x, then you just use your calculator, draw y equal to x. Then you just, by looking at the graph, you can find the solution. But be careful about asymptote, especially vertical asymptote. So yeah, that's it. It's question 8. For me, the most interesting question in this paper is question 7. Let's do question A and B. These two are like some general question. So, the first two terms of geometric sequence UN are U1 equal to 4 and U2 equal to 4.2. U1 equal to 4. U2 equal to 4.2. And because we know that UN is equal to U1 times R to the power of n minus 1. So we know that U2 should equal to U1 times R to the power of n minus 1. N is 2 minus 1. So equal to U1 times R. So we know that U2 is 4.2, U1 is 4. Therefore, we know that R is equal 4.2 over 4, which is equal to 1.05. Hence, or otherwise, find U5. U5, yes, we can use 4 you can use u1, same formula, u1 times r to the power of 5 minus 1, which is equal 4 times 1.05 to the power of 4. So just calculate it by calculator in general. And another sequence Vn is defined by Vn equal a times n to the power of k, where a and k is a real number and n is positive integer. It's really interesting, such that v1 equal to 0.05 and v2 equal to 0.25. Then find the value of a and find the value of k. So yes, according to the definition, v1 is equal to a times 1 to the power of k, and v2 is equal to a times 2 to the power of k. And we know that v1 is equal to 0.05, v2 is equal to 0.25. Let's compare these two stuff. The thing is, guys, 1 to the power of anything, since k is real number, this term should equal to 1. So we know that a is equal to 0.05. Therefore, we put 0.05 in here, we will get 0.05 times 2 to the power of k is equal to 0.25. Therefore, 2 to the power of k is equal to 5. K is equal to log 5 raised to the base of 2. That's it. I mean, if you want, you can write exactly the value here. Then the question C is the thing I wanna talk about it. Really want to talk about it because it's really interesting. So find the smallest value of n of which Vn more than Un. Obviously, when we talk about sequence, n is a positive integer. So yeah, in the mark scheme, you guys saw that you can test each n. So you will find the answer is 8, I think, right? I remember it's 8. But actually, here's another way to do that. Here's another way to find the smallest value of n. Listen, even though n is an integer, but we still can ignore it. What I mean is, think about this equation, for example, or formula. Un is equal u1 times r to the power of n minus 1. Basically, it's you can imagine that this equation is a function, but the input is always integer. So un is equal to u1. U1 is should be a constant. R is also a constant. We know R, and the variable is n. So n is input, un is output. Actually, it's a function, but the input is always integer. For this, it's same. Vn is equal a times n to the power of k. A is a constant, k is a constant. Vn is output, n is input. It's also a function, but the input is integer, positive integer in this case. But the thing is, if I have a question. If we want to draw the graph for this two function on the plane. Yeah, there will be only like some dot, right? But in fact, this two stuff it themselves is already a function. It's a continuous function, actually. Therefore, you can use calculator to draw the graph of this and this. So, I don't know if it is allowed, but you can write, on the paper, you can write, assume function u, which is like ux equal to u1, which is 4. Like ux equal u1 times r to the power of x minus 1, which is 4 times 1.05 to the power of x minus 1. It is first function. Second function, vx is equal to ax to the power of k, which is equal to 0.05 times x to the power of log 2. Show the examiner this and draw this two graph in your calculator. Then you can write down when x equal to x0. Yeah. In this case, there's only one. The graph should look like that. So it's like when x equal to x0, you can tell the examiner ux is equal to bx. Therefore, you know that the smallest value of n, which is vn more than un, you should find the smallest integer, which is more than x0. So you should also get the same answer. So look at the screen.
So this is the graph of these two functions. So basically, we transferred a sequence question to function question. So we can see that the intersection of these two functions is 7.6.5.5. So we can, according to the graph, we know that the smallest possible value of n is 8 because n is a positive integer. So like that. And I mean, if you really want to treat it as a sequence, so you'd only have to draw like a few points when x coordinate is positive integer. So then the graph won't be continuous, but with some point. So you still can see the answer, but this graph is easier, isn't it? Instead of testing each n or using inequality way to solve it, I think this one is much more better.
Yes, so you guys already saw the GeoGebra. I use GeoGebra to draw the graph, and you guys will see like the intersect, and you guys will understand what I mean about function. Use function to replace like the equation here. It's easier to find the smallest value because graph is more like obvious, right? That's it. It's all the questions from the paper I want to talk about. And good luck tomorrow. Baba boy.